Alright, so here I am, continuing to work through the AP Physics 1 algebra-based free response questions. This is the 2017 version. The link will be down below. They posted this online, so I'm going to use it. Working through this, doing whatever I can. I have not looked at this. I have my other... I'll put a playlist with my other answers in there in case you're looking for them. So let's just get started and then turn off the screen because you don't really want to see me. Okay, move the mic a little bit. Ooh, not that much. Okay. So I already did questions 1, 2, and 3. I'm on question 4. Oh, excited. Oh, crap. You okay? I'm okay. Okay. Sorry about the hit of the mic. That was my fault. I'm a noob. So here we have the question. A physics class, the whole class, is asked to design a low friction slide that will launch a block horizontally from the top of a lab table. Teams 1 and 2 assemble the slides shown above. I think it's like that. Use identical blocks 1 and 2 respectively. Both slides start at the same height D above the tabletop. However, Team 2's table is lower than Team 1's table. To compensate for the lower table, Team 2 constructs the right end of the slide to rise above the tabletop so the block leaves the slide horizontally at the same height H above the floor. Okay, so this block comes down and launches. This block comes down lower and then goes up and then launches. Where were we? Okay. Both blocks are released from rest at the top of the respective slides. Do block 1 and block 2 land the same distance from the tables? Yes. Okay, so if we use this an energy problem, so there's really two parts to this. Number 1 is the launch velocity. I'll call that V0, and it's technically a vector right there. So how do the V0s compare for this? Well, if I say this is y equals 0, and my system is the block plus the earth, then there's no work done. Work is 0 because what forces act on the block? Well, as this thing slides down, there is a force from the ramp, a normal force. However, that's always perpendicular to the displacement. So the work is F dot delta R is 0. Because these are perpendicular. So the normal force doesn't work. Now, the other force on there is the gravitational force, but that's part of the system, so it doesn't do any work. That means the work is equal to the change in kinetic energy plus the change in potential energy. So let's call this Y1, and let's call this Y2, where it ends up. So for this case, and it starts from rest, so I have 0 equals 1/2 m v2 squared. Well, I guess I should call that I got that mixed up a little bit. That's fine. Minus 1/2 m v1 squared plus m g y2 minus m g y1. So this is going to be equal to d. This is going to be equal to 0. This is equal to 0. So 0 equals 1/2 m v2 squared minus mgd. Right, because that's the change in height. That's that one. Now what's different about this one? Oh. Wait, okay, no, I'm sorry. They don't have the same change in height. So if this one ends up at y equals 0, this one starts off, they don't tell you the difference. This one starts off a little bit lower. So this is not a delta H, a change in y of d. So this is actually going to be, this is for the block 1. For block 2, it's going to be equal to 0 equals 1/2 m v2 squared minus 0, that one's 0, plus the final potential energy is 0, mg y2 0, minus mg d minus delta, where delta is this difference in height. So this one's going to end up with a lower velocity launch off. They will not have the same velocities. They're the same height, but they didn't start at the same height. Okay, so this one, now we're going to the second part. Which one's going to go farther? Now it's just normal projectile motion. This one's going to take a longer delta time, right? Let's set up the projectile motion. So here is the block launched off the table with some initial velocity v0 in the x direction. It's horizontal. I can break this into two motions, an x motion. So in the x motion, I have, and this is going to be called, let's call this x2, and x1 is 0. So I have x2 equals x1 plus v0 delta t. Right? That's because this is moving at a constant horizontal velocity, because once it's in the air, the only force acting on it is the downward gravitational force. So that's true. Now, I don't know the time, but if I look at the y motion, I can find the time. So for the y motion, this is, I already called this y equals 0. So this is y1 equals 0, y2 is going to be equal to negative h for block 1. So for block 1, for both of them actually. So for this I could say y2 equals y1 plus vy0 delta t minus 1/2 g delta t squared. So in this case, it starts with an initial y velocity of 0, and it starts at y equals 0. And y2 is negative h equals negative 1/2 g delta t squared. Delta t is going to be equal to 2h over g square root. Put that in up there. Okay, so that will tell me how far it went. And the thing is, if I launch it from a greater height, if h is greater, delta t is greater, so it's going to go further. So the second one's launched at a lower height, it'll have a shorter time and a shorter displacement. Was that too much justification, or is that enough? That may have been too much. In another experiment, teams 1 and 2 use tables with low friction slides with the same height. However, the two slides have have different shapes. So this one just goes down. I don't know, is it a parabola or a circle? And this one is a curved shape. Both blocks are released from rest at the top of their slides. Which block lands farther from the table? They land the same. So in this case, it's the same thing, right? I can still use work energy. Work is the change in kinetic plus a change in potential, and the work is 0 because it doesn't matter what the shape of this is. The normal force is perpendicular to the displacement, so it does no work, and that means that all that matters is the change in kinetic and potential energies. They start with the same kinetic energy, they have the same change in potential energy, so they end up with the same velocity, and then they go the same height to the table. This says without manipulating equations. Okay, I did. I didn't write it down though. Which block, if either, hits the floor first? Now, this one's a little bit trickier. Okay, so the answer is block 1. So this is like the Brachistochrone problem that says what's the path that takes the shortest amount of time? And it's not so trivial, but you can kind of reason it out. So this one, in this case, actually, I'm not sure which path is the longest. It's hard to tell. Let's see, so that's the shortest path. That one looks closer to the shortest path, so this one might be a longer path. But this one increases in speed really quickly. And then so it takes a larger distance, but now it's going at a greater speed, so it's going to get there faster. This one starts off actually very slow because the steep is very slow. So this part of the graph of the slide is going to go slow, and then it's going to start speeding up. So it's going to waste a bunch of time up here, whereas this one gets going right away. So this one's going to they're going to have the same speed at the bottom, but this one's going to get there first. And since it gets there first, it's going to hit the ground first. Is that okay? I don't really like that question. Okay, that's it. I don't want to look at question 5. That is question 5. Yeah, I kind of looked at it just to make sure it wasn't question 4. Okay, so I'll stop there. Not really. I'm really just looking for some more complicated questions that dealt with actual solving problems. I think someone told me the AP Physics version C has more calculations. So I'll finish this and I'll do that one. So I'll talk to you guys later.